Hello my dear friends, how are you all? I hope you all are good and fantastic. So my dear friends, you are very welcome in our lecture number 4. Okay, so my dear friends, I hope you will enjoy this lecture. So without wasting the time, let's start. Yes, so my dear friends, today we are going to discuss theorem based on the tangents. Okay, yes. So the first theorem is, okay, the tangent at any point. First term is what? The tangent at any point of a circle is perpendicular to the radius through the point of contact. Means the tangent at any point of a circle is perpendicular to the radius through the point of the contact. Okay my dear friends, means it is saying that, let's suppose we have a circle. Okay, so this is a circle and this is what? This is a tangent of a circle. Now the theorem states that the tangent at any point of a circle is perpendicular to the radius through the point. Means this is what? This is perpendicular. Okay, this is radius, this is center O. So my dear friends, I hope you understand this statement, this theorem. Okay my dear friends, so the tangent at any point of a circle is the perpendicular to the radius through the point of contact. Okay, so now let's take the proof of this theorem. So if you see that, here is, we have a circle and a tangent and a perpendicular line. Okay, now this is A, this point is B. Okay, this point is A, this point is B. Now we are taking this point is C. This point is what? C. Okay, now take a point D on tangent AB. Tangent AB other than C. Now we have to take the point D anywhere except point C. So now let's take the point D here. We are taking the point D here. Now join OD. Okay, now we have to join OD. Now from point D, this point, if we see this point lie outside the circle. This point is lie outside the circle. Okay, because if point D, if let's suppose we take the point D inside the circle, then AB will be a second. Then AB is what? Then AB will be a second. Then AB is like this. This is not a tangent. This is a straight line. Okay, this is not a tangent. So that's why we are taking D as the outside of the circle. Okay my dear friends, so point D should be lie outside the circle. Okay, now this line, therefore OD will be greater than the radius of the circle. OD will be greater than the radius of the circle. What is the radius? Radius is OC. Radius is OC. OD will be greater than the radius of the circle OC. This happens for every point on AB except this point of contact C. So this will happen on every point of AB except point C. If we take this point, if we draw a line, and we see that this point, this line is also greater than AC. If we take this line is also greater than OC. Okay, so it can be concluded that what? OC is the shortest distance, because it is a perpendicular distance. So OC is the shortest distance between the center of a circle O and line segment AB. Since the shortest distance between a point and a line is always a perpendicular distance between them. Okay, so let's suppose we have a line and we have a point P. If we draw a lot of lines from point B, all the lines are greater than the perpendicular line. So we can say the shortest distance between the point and line is called the perpendicular line. So my dear friends, I hope you understand these things. So here we can say that it can be concluded that OC is the shortest distance. OC is the shortest distance between the center of circle O, okay, and tangent AB. Okay, my dear friend. So we know that the shortest distance between a point and a line is OC is perpendicular to AB. So my dear friends, I hope you understand this concept. This is the theorem 1. So what is the theorem? So this theorem states that the tangent at any point of a circle, is perpendicular to the radius through the point of contact. Okay. So now from the above discussion, from this discussion, it can be concluded that it can be concluded that what? First point is the tangent touches the circle. The tangent touches the circle at only one point. What? Yeah, from this discussion we can say that the tangent touches the circle at only and only one point. Okay, so second point is that we can call the line containing the radius through the point of contact as normal to the circle at the point. We can call the line containing the radius through the point of contact as normal to the circle at the point. Okay, my dear friends, so we can call the line containing the radius through the point of contact as normal to the circle at the point. Okay, so I hope you understand these things. So this is our theorem number 1. So now let's move on to the theorem number 2. So the theorem 2 states that the length of tangent drawn from an external point to a circle are equal. What is this theorem? The length of tangents drawn from an external point of a circle are what? Are equal. Okay, my dear friends. So let's suppose we have a circle like this. Okay, this is a circle. Now the statement says that the length of tangent drawn from an external point of the circle. Okay, so now this is the external point and we have to draw two tangents like this. This is point P, this is point Q, this is point R, and here is the center. Now this theorem states that according to this theorem, PQ is equals to PR. Okay, my dear friends. PQ is equals to what? PQ is always equals to PR. These two tangents are always equal. These two tangents are what? Yes, these two tangents are always equal. Okay, so let's see the proof of this theorem. Yes. Proof of theorem second. Okay, now we have a circle like this and we have two tangents, tangent 1 and tangent 2. This is the point P, this point is Q and this point is R. We have to prove PQ is equals to PR. Okay, my dear friends. So now for this, first of all, we have to join, this is center O, we have to join PO, okay, OQ and OR. Okay, now let's join this. OQ, OR, this, and OP. Okay, my dear friends. So now, and here is angle OQP and angle ORP is what? angle OQP and angle ORP are right angle. Are what? Right angle. Means these angles are right angle because what? Because these angles are between the radius and tangents. The radius and tangents. And according to theorem 1 also. Okay, so this is the distance between the perpendicular line tangent this and the radius OA. So this is the perpendicular angle. Okay, so now my dear friends, I hope you get this point. Now in triangle OPQ and triangle OPR, okay, we know that OQ is equals to OR. Why? They are radius. They are what? Radius. Okay, and OP is equals to OP because of common, because this line is common in triangle. This is OPQ and OPR. This side is equals to this side, and this is what? Yes, this is common. And angle OQP is equals to angle ORP is equals to what? 90 degree. Okay, so we can write here like triangle OPQ is congruent to triangle OPR. Okay, my dear friends, by what rule? By RHS rule. And what is RHS rule? RHS rule is right angle hypotenuse side rule. Means in this rule two triangles are congruent when there at least when in those triangles there is at least one right angle, okay, and one hypotenuse are equal and one side are equal, then we can say that these triangles are congruent by RHS rule. So in this case one side is common, one side is equal, and OP is common, which is hypotenuse, and one angle is 90 degree. Okay, my dear friends, I hope you get this point. So now we can write here is PQ is equals to P is equals to what? PR. Okay. So my dear friends, I hope you get this point. PQ is equals to PR. So this is the proof of, this is the what? Proof of theorem second. We can write it here, hence proof. Okay. PQ is equals to PR. So my dear friends, I hope you get this point. So now let's move on. Now the interesting facts about circle and its properties. What are the facts? So the first is In two concentric circles, the chord of the larger circle which touches the small circle, smaller circle, is bisected at the point of contact. Okay. Now, in two concentric circle, okay, two concentric circles, the chord of the larger circle, which touches the smaller circle, smaller circle, is bisected at the point of contact. Okay, my dear friends. So, according to this statement, let's suppose we have a circle like this. This is center O, and with the same center we have another circle which is concentric circle. Now, according to this statement, the chord of a larger circle which touches the smaller circle means like this. Okay, this is a chord of circle C1, and this is which touches the circle C2. This is point A, this is point B, and this is point P. Okay, so according to this question, the chord of the larger circle which touches the smaller circle is bisected at the point of contact. So what is the point of contact? P. So we can say that AP is equals to PB. This is the property of the circle. Okay, so my dear friends, I hope you get this point, that when the chord of a circle touches the smaller circle in two concentric circle, okay, so that chord is bisected at the point of contact. At the point of what? At the point of contact. Okay, so now let's move to the second property. Second property is states that the tangent drawn at the end of the diameter of a circle are parallel. The tangent drawn at the ends of a diameter of a circle are parallel. Means it is saying that we have a circle like this. Okay, this is center. From this center we have a diameter. Now if we draw the tangent from the ends of the diameter, let's suppose this is the tangent from this point and another tangent is this. Okay, so these tangents are what? These tangents are parallel to each other. Means, let's suppose we have name is L1 and this is L2. So we can say that L1 is parallel to L1 is what? Is parallel to L2. Okay, so my dear friends, I hope you understand these things. So now let's move on. So the third property is that the perpendicular at the point of contact to the tangent to a circle passes through the center. Okay, the perpendicular at the point of contact to the tangent to a circle passes through the center passes through the center. Okay, my dear friends, so the perpendicular at the point of contact to the tangent to a circle passes through the center means, okay, means let's suppose we have a circle like this and we have a tangent. So this statement states that the perpendicular at the point of contact to the tangent to a circle means this is point of contact, and perpendicular from this point of contact, this is perpendicular line, so this is passing through the center of a circle. This is passing through the center of a circle. Okay, my dear friends, I hope you get this point. So now let's move on. So next important property is that property number 4, the angle between the two tangents, draw from an external point, in a circle. Okay, my dear friends, so the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment, joining the points of contact at the center. So my dear friends, this statement states that, okay, let's suppose we have a circle like this. Okay, now from point P we are drawing two tangents. These are the tangents. This is center O. Okay, now we are joining this from center. These are perpendicular. This is A, B. So this statement states that two tangents drawn from an external point in a circle is supplementary. The angle between the tangents drawn from an external point in a circle is supplementary to the angle subtended by the line segment joining the points of the contact at the center, means we are talking about these lines. So the angle 1 and angle 2. Okay, so now according to this statement we can say that angle APB plus angle AOB is equals to 180 degree. 180 degree. Here is the supplementary means two angles having the sum is what? 180 degree. So that's why these angles are called supplementary angles. Okay, my dear friends, I hope you understand these things. So now let's move on. Yeah, so the next property number 5 is the parallelogram circumscribe a circle. The parallelogram circumscribing a circle is a rhombus. Means the parallelogram circumscribing a circle is a rhombus. Okay, so now this statement states that, let's suppose we have a parallelogram like this. Okay, parallelogram like this: A, B, C and D. And in this parallelogram there is a circle with touching these lines. Assuming that this is a circle. Okay, this is a circle. Assume that. Okay, let's suppose this is a circle and touch at point P, Q, R and S. So according to this statement, we can say that ABCD is a rhombus. ABCD is what? Is a rhombus. Okay, so now let's move to the next property. The next property is property number 6 is that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angle at the center of the circle. Means the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Okay, my dear friends. Okay, so now let's suppose we have a circle like this. Now a quadrilateral like this. This is a quadrilateral. A, B, C and D. So the opposite sides of a quadrilateral circumscribe a circle subtend supplementary angles at the center of a circle. Means let's suppose these are the opposite sides. Okay, now according to this statement, this is center O. This is the center of the circle. Okay, according to this statement, angle BOA plus angle COD is always equals to 180 degree. So this is the statement of this properties. Okay, my dear friends. So my dear friends, I hope you understand these things. Okay, so now this is enough for today, and we will meet in the next lecture with the amazing topic. So now thank you very much guys for listening me, and take care and goodbye.